Alright, this is part 2 of trigonometric equations. Alright, so here are the directions again. Solve analytically over the interval 0 to 2 pi. So we're looking for all the solutions between 0 and 2 pi. Alright, so here's our first example. The cosine of 2x equals negative 1/2. Now, we know that for cosine x, the domain is 0 is less than or equal to x is less than 2 pi, right? For is less than or equal to pi for one revolution around the circle. Okay, so then we don't have x over here, right? We're taking the cosine of 2x. Our angle is 2 times x. So for cosine of 2x, then the domain would be 0 is less than or equal to 2x is less than or equal to 4 pi. Essentially, we multiplied all three parts here by 2, right? And so if we want x to be between 0 and 2 pi, then 2x has to be between 0 and 4 pi. Make sense? Right, so then what we're looking for is we want to list out all the angles that have a cosine that's negative 1/2 between 0 and 4 pi. So we're going to go around that unit circle twice. Okay, so doing that, we list, so 2x, the angle, the angle's 2x here, is equal to, right, 2 pi over 3, because the cosine of 2 pi over 3 is negative 1/2. 4 pi over 3, and then going around the circle again, we're going to have 8 pi over 3, and then finally 10 pi over 3. All right, all four of these numbers here are between 0 and 4 pi. Okay, and then to isolate x, what do you think we're going to do? All right, thus x equals divide everything by 2. So you get pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Right? So there are 4 numbers here, and notice that all 4 of these numbers are between 0 and 2 pi. Right? Remember, we're looking for all the solutions to this equation that are between 0 and 2 pi. Well, there are 4 of them now. If you take any one of these numbers and plug them in up here for x, you will get a true statement. All right, so if, graphically, just real quick, sketch out the graph. 1, 2. Okay, so forth and so on. All right, here's 2 pi, and here's 4 pi. Okay, and then negative 1/2 would be down here. Okay, and there are the 4 places that your graph hits. Okay, and it'll be these numbers: pi over 3. 2 pi over 3, 4 pi over 3, and 5 pi over 3. All right, so let's look at the next one. So the first thing we want to do is to isolate the trig function. So sine of x over 2 equals 1/2. Now, if normally we've got x going between 0 and 2 pi, then where is x over 2 going to be between? Then 0 is less than x over 2. Less than or equal to pi. All right, so now we're looking for, because our angle is x over 2, so we're looking for all numbers between 0 and pi, all numbers between 0 and pi that have a sign that's equal to 1/2. Well, that would be pi over 6 and 5 pi over 6. Everybody agree? Okay, so therefore, x would equal, multiply everything by 2. So you get pi over 3 and 5 pi over 3. And those are your two solutions. If you take either one of those numbers and substitute them up here for x, you'll get a true statement. All right? Kind of getting the hang of it? All right, so let's look at one more example. Right off the bat, we can see we can divide both sides by 2. So that would leave you the sine of theta equals the cosine of 2 theta. Now we need to use some trig identities because we've got 2 different trig functions going on. So we notice that cosine of 2 theta could be written as 1 minus 2 sine squared theta. Right? The reason why I chose that one, remember there were like 3 identities for the cosine of 2 theta, right? The reason why I chose that one is because we're getting everything in terms of sine. So you just have sine theta running around, right? So then we have 2 sine squared theta, moving that over, plus sine theta minus 1 is equal to 0. So I'm just moving everything to one side because it kind of looks like a quadratic equation. You follow me there? You got sine squared and just sine and then no sine. So it kind of resembles a quadratic equation. And then, well, let's see if it factors. And if it doesn't factor, we can always use the quadratic formula. Check out that last video if you need to see an example of that. But I think in this one, it factors. So let's see, 2 sine theta and 1. And sine theta and 1. All right, so what are the signs? Looks like that one's going to be a plus, and that one's going to be a minus. All right, and then you have 2 factors whose product is equal to 0, so set each factor equal to 0. So 2 sine theta minus 1 equals 0, and sine theta plus 1 equals 0. So sine theta equals a half, and sine theta equals -1. Well, here's an example where we don't have to mess with the domain, right? Because it's just the sine of theta is equal to half. So if you're going between 0 and 2 pi, theta, which angles have a sine that's equal to half? Well, that's pi over 6 and 5 pi over 6. Right? And then sine of theta equals -1. Well, what angle has a sine that's equal to -1? Well, that's 3 pi over 2. Right, so there are 3 solutions, pi over 6, 5 pi over 6, and 3 pi over 2. You don't even have to mess with that domain situation like we had back here where you got x between 0 and 2 pi, but you want to know where the cosine of 2x is, and so you have to say, all right, expand it out. So 2x is going to go between 0 and 4 pi, and you list out all those solutions and then divide. Right? You don't even have to mess with that in this particular case because we were able to get rid of the double angle by a trig identity that just worked out to just a regular quadratic equation. All right, so make note there's sometimes trig identities will come in handy to help you, just rewrite your equation a different way where you don't even have to mess with the double or half angles or triple angles or whatever. And sometimes you're going to have to mess with the domain, like that example or like that example, right, when you mess with the domain. All right, that's it. Study well, and please let me know if you have any questions.